Hi everyone. Today this will be a two-part series on showing how to drive a wheel using custom made axles and plates. And today will be part one, where I will be showing how you can make custom parts, especially plates that will serve as the bearing holders for the wheel to connect to the axle. So right now, if you see, this is a very basic TETRIX chassis. The goal is this would be the outside of the robot, this would be the inside, and then we will be having these two channels as the place where this mechanical wheel would sit at the center. So if you're going to drive this using an axle and a few bearings, what we need to have is first an axle that goes through these circles, through these holes. Second, a plate that connects the axle to the bearing to the wheel. And those are basically the two parts that we need, with the requirements for other parts might arise when you're making this. So let us begin by using the top-down approach, where we will first start off by making a plate that will fit this part. So let's insert a new component, a new part on this plane. And then let's make a sketch. This sketch will be a little larger, just right here. We're going to first start off by We're going to start off by using the convert entities feature. We'll be copying these circles, 2, 3, 4, 5, 6, and we want to make all of these for now for construction. So because you have to make the hole a little larger for the CNC milling machine, it actually might be better to just drill holes out because it's not a lot of holes. So let's define the size of this plate. That and this circle should be equals. And now we also need to give it a hole right here. And since this hole is 8 millimeters in diameter, we should think that around 10 millimeters for this one would be sufficient. So let's give that 10 millimeters. This design choice I will explain a little bit later on. Let's say we're using 3T plates, and this would be enough. And of course we would need to approach the sprocket over here, but then let's try to see if the sprocket is going to be far enough out. If you see, it seems that the sprocket may be hitting the sides a little. So we will want to make something that push the sprocket through. So something that we'll have to do very first is drill holes in here so that we can screw on the sprocket onto the side plate. Let's see. The distance between these are 16 millimeters, and these are 6-32 holes. So let's revise the sketch. Make a new folder. Video 7. Let's edit this like a circle. Distance would be 8. size would be 3.7. Let's define this a little better so it's vertical. And circular sketch pattern. And 4. Yes. Now we have this. It will be like this now. And let's give these a few mates, but then in order to increase the distance, we may want to make a new part that stands off from here around 4 millimeters far. Let's insert another component in this plane, and let's convert these, not the planes, just the circles, this as well, like this. Let's extrude that extrude it 4 millimeters far. And now I believe if we mate these two, it should be good. Yes, it's far enough out for us to use. And for now, let's undo the coincidence so that we can design this a little better. Now, we'll have an axle going through this circle that is 8 millimeters thick, and we want it to become thicker later on. Right here, I'll show you how I want it to look like. So I want the axle to look something like this, because if we do this, we can, by screwing the plates onto the wheel, we can easily and very strongly connect the axle to the wheel. And in order to do that, we will need bearings. That means that on this side, the bearing would be 8 millimeters. The axle will be 8 millimeters thick. Inside here, it will be 10 millimeters thick, and outside is going to be 8 again. And that means that the bearing that we need is 8 millimeters in inner diameter. So let's go and look for a flange bearing with an ID of 8. Let's see if they have a CAD file. Agree. So okay, no CAD data for this, but then as you might know, bearings have all very standardized shapes, so we can just use this as a CAD file. It's complete. Let's get on with downloading. You want the step file. Wait for it to generate. Let's open that up and go and copy this into our folder. And let's open it up in SolidWorks. This time, just to show you how, let's try to proceed with feature recognition. It's a very, very simple shape because it's a simple revolve feature in this case. Let's save this into flange ID 8. And we'll go to insert this part in the assembly. And to show you how it looks like, let me just take this out and show you some design changes that we may have to make to this. Let's fix this for comfort. And okay. So I connected this bearing right here. In order for us to make it work, what we'll end up having to do is something that may make it easier for us to get the parts that we want is to face mill this part so that the axle's inside length, where it needs to be a little thicker, is equal. For example, the axle's ordinary length should be the distance between these two, which is this plate and this plate. The distance is 38.68, with the normal distance is 27.94, and it's a very weird distance. And what we can end up doing is we can actually face mill this plate so that the flange bearing goes a little inside, and thus makes the inside length of the axle very nice. It was 94, so if we that's 0.06 millimeters. If we face mill is 0.03 millimeters, then we should probably have a very nice length defined for this. So the outer diameter of this bearing is 13.6. Let's this part, add a sketch. .6 0.03. And now if you get rid of let's get rid of the flange bearing and see how it looks like. It's a little bit face milled. And this means that if we put the circle here and put that here as well, the bearing goes just a little bit inside. And let's unfix this. Float. And let's give that side a bearing as well. Like this. And then here. And we can go ahead and connect this with the circle here. Like this. And now let's try to find the distance. So for now, let's make that wireframe so that it's easier for us to select these. This part and this part. No, instead of wireframe, let's get rid of it from the assembly for a very short amount of time. So suppressing this configuration. The distance between these two are 26.40. Let's just make that 26, and no, 20.460 is okay. Let's face mill it 0.3 millimeters more so that it becomes a nice whole number. And let's unsuppress this. Unsuppress. And if you try to get the distance once again, select. That's a very clean whole number, and it should be easier to, and that's if you ever end up making an axle that fits this should be a much cleaner one to make. Let's make this look what it looked like before. Now we have this part done. Let's fix these two up. And now we know that we want this to go inside here. And how are we going to make an axle that fits this perfectly? And that is something that I'm going to save for the next video. So thank you very much. All the parts that we made today, especially this one and that one, those are the ones that we would take to a machining shop to carve, to use a CNC mill to make. And this, seeing it from even now, is a much simpler way of connecting this wheel to the TETRIX chassis as we compared to the one that we have done before. So thank you very much, and I will see you again in the next video.